Good morning. My name's Gary Lewis. I work here at the church, actually. I'm on staff here at the church. But my background, to kind of give you a little bit about myself, so you're not wondering who is this guy that's talking to us. My background, after I graduated from high school, back when the dinosaurs roamed the earth, I went into the Navy and I learned electronics, and I worked on radios, on shipboard radios. And when I got out of the Navy, I went back to school, went to college, and I thought about going into computer science, but what I found when I looked at the curriculums, a lot of it dealt with hardware, and I had kind of already learned all that in the Navy, so I didn't want to go through all that again. So I went through a business curriculum that was information technology. I learned all about programming and systems and so on and so forth. So when I graduated from college, I had a degree. I had a business degree, but it was in what was called MIS, or Management Information Systems. And so I was kind of one of these rare ducks that not only knew the business side and IT from that side of it, but I also had the hardware background. And so when somebody would look at my resume, when they saw I have MIS, they kind of know, okay, this is a business guy that knows some programming and so on, but they were kind of shocked to find out that I knew all this stuff about hardware. When I got out of college, I went and worked for the oil industry for about 8 years, and then after that, I went to work for IBM, and at the end of 2013, I retired from IBM after 25 years. Had varied backgrounds in IBM. I was not only a technical person, but I was also in management for a period of time. And I also wore different hats during that career. I did some programming early on. I was a database administrator for many years. I did system administration on Unix systems, which is another flavor of what you're using with your little Raspberry Pis, which is Linux came out many years later. Unix was developed by AT&T many moons ago. But I've seen over the years the computer industry go from first computers that I worked on. The computer in college that I used was a Burroughs computer that filled a room that was probably half the size of this building, and it was water cooled. So I've seen the computer industry go from that to the Apple iWatch now, that you have all this computing power on your wrist. Very first business computer I worked on was an IBM 360. The 360 came out in 1965, way before you guys were born. And that particular computer had 8K of memory. We had to process payroll and different things on that computer in a certain sequence, otherwise it would blow the computer up. It was so limited at what it could do. Give you an idea, the computer that was used on the moon lander in 1969 was actually IBM was involved in building that computer along with MIT and some other people. It was about the size of it was like a box. Could only write in assembly language. If you've seen some of the movies where they portray they're having to put commands into it, they'd have to put noun, verbs, so on and so forth. That's how assembly language worked. That particular computer had about 8K of memory as well. And so you've got more computing power in your wristwatch nowadays than they did back dream job in IBM was what's called an IT architect. And that's kind of a fancy term for someone who designs things. What I would do is design systems, or if I was doing a database system or some computer system that we were designing, I would lay out the design of it, but then I would turn that design over to a set of people that would actually code things or come up with the database designs and so on. So I would pretty much lay out the overall design of things. So I know you've been, your theme this semester, or this particular time that you're working on right now, is bearing fruit, as I understand. One of the things you have to do in programming, I was asking Ms. Rose what, kind of where you're at in your class, and there's a lot of different aspects to programming. One of the things that you're going to have to learn in programming is you have to be able to prove that your program is actually doing what it's supposed to do, or what it was designed to do, okay? And so in other words, you want to make sure your program is bearing the right fruit, as it were. And how we do that in testing, and I just kind of wanted to give you an example. Let's say I have a program, this is represented by this square here, a program that I'm going to search a text file, a document file, just plain text, that for a particular word, okay, could be any word. What are the two inputs to this program? Anybody?
What word to search for?
Okay, yeah, you're gonna have a word, could be any word. Okay, so that's one input to this program. What's the other input? Okay.
The file that needs to be searched.
Yeah, the actual file that needs to be searched, exactly. And what's the output of the program?
The search result?
Yeah, the search result, or well, let's say I'm gonna have it count the number of words that are in that file, okay? What's gonna be the output?
Numeric value represented.
Yeah, you're gonna have a number that, and you could display that number on a screen, you could print it out on a piece of paper, you could store it in a file, or you could do all three. So how could I test, what would I construct in order to test this out? This is called a test case, by the way. So I'm gonna develop a test case so I can prove that this program is bearing fruit, or the right fruit, let's say. Well, let me help you out here. What we would have to do is we'd have to come up with a test file. It could be any text file. And we would manually have to go in, and let's say I'm gonna look for the word big, okay? I would have to go into that file and I have to manually count, okay, I've got 5 occurrences of big, so what I should see at the end of this program is the number 5. Okay? So that's my test case. So I put in the word big and I run this program, and if I don't come up with 5, then it's not bearing the right fruit. Something in my code is not right. Okay. So that is what is called, in the programming world, is called unit testing. I can't write here. We're actually testing the program as a single unit, okay, to see if it's bearing the right fruit. If you write that program and then you program A and you write program B, and those two programs are supposed to talk to each other. So first you're gonna have to test your program to make sure it's running right. You're gonna have to make sure your program runs right. Let's say you're in charge of, you've written some code to kind of tie these two together. In order to test all of that together, it's called a functional verification test. Another example of something is once it gets up to that level, let's say a user is interacting with this, then we'll have a user verification test where we may have test cases that are associated with that. You know, what a user is expecting to see. Is it bearing fruit in that regard? Then we've got another one. If we're going to integrate this with hardware or something else, called a system integration test, where we're not only testing the interaction of this whole thing with some hardware or something else. So there's a lot of different levels of testing that can go on to make sure that things are bearing fruit. And you see all this stuff in the industry. Well, I'm not actually here, believe it or not, to talk to you about testing today. But we see another area that I became very involved with, and we see this in this area as well, is ham radio. And give you a little bit more background on this. My son, we home educated my son all the way through till he went to Laterno. In fact, we were part of Czech years ago when it first came about. And we originally were in California. We lived in California for 30 years before we came back to Texas. Actually, it was the Navy that took me out there. And when our son was about 12 years old, he expressed an interest in ham radio. This was back in the year 2000. And so I thought, well, let's both of us together, let's see if we can get licensed in ham radio. Let's study to become licensed. I had the electronics background, I had the radio background, so I felt that, you know, I had friends many years ago that were involved in ham radio, but I had just never become licensed. I knew all of the technical part of it, but just never did it. So we became licensed, and kind of things went on in that regard. But in terms of this kind of testing, we see this in ham radio as well. When we set up for like emergency communications, we will set up systems out in the field, and we will have to test those systems. And the test in that sense is, can I communicate with somebody on the other end that I need to be able to communicate with? And so all those systems have to be able to work together. Well, what I'm going to do today is I'm going to show you some examples of how we use this little computer that you're using in your class, the Raspberry Pi, how we use that in ham radio, some applications of that. I'm going to talk to you specifically about one of them. But in order to do that, I'm going to kind of have to give you a little bit of background into ham radio, or radio in general, so it kind of gives you the context in which this little guy operates within ham radio. And we're actually going to demo something here a little bit later. Got to keep an eye on the time here. Radio is, if you look at a radio, basically a radio, what it does is it takes your voice, which is an audio signal. Your voice carries probably about somewhere between 1,000 up to 20,000 hertz or cycles per second. That's what an audio signal, if you listen to your iPhone music from iTunes or whatever, that's the frequency that you're listening at for audio. What a radio does is it takes that audio signal, and through a bunch of circuitry in the radio, it converts that audio signal into a radio frequency signal. And radios operate at different frequencies. Some of them operate at very low frequencies, some at very, very high frequencies. And we have radio waves, what travels through the air, these invisible waves. They travel at the speed of light. They travel in different ways. On very low frequency radios, they travel along the ground. It's called a ground wave. Okay. If the higher frequencies, like what we call VHF or UHF, very high frequency or ultra high frequency, or what we call line of sight type of communication. So if I have a handheld, like this little guy right here, and you have a handheld, actually these only, like a walkie-talkie, this particular radio only puts out about 5 watts at most. And so you can't be too far away for me to talk to you, but this radio talks in what we call line of sight. If I can see you, then I can, communicate with you as long as you're not too far away from me because of the wattage that it puts out. But what happens if, and this is represented by this dashed line, what happens if there's a mountain in between us? We're not gonna be able to communicate with each other because there's an obstruction, or if there's a big building in between us. So what happens is, a lot of times when you have an area where there's a lot of hills or mountains in the area, what they do is they put a device on top of the mountain. It's a thing called a repeater. And a repeater is a system. It's composed of 2 radios. One is a receive radio and one is a transmit radio. So what happens is when I call you on my radio, the repeater's receiver, the receive radio picks it up, and then it retransmits it at a higher power on the transmit side of the repeater. And so if this mountain is between you and I, what happens, I communicate with the repeater, and then you're able to hear me on the other side of the mountain, okay? Still line of sight communications, but the line of sight is between you and the repeater, not between the 2 of us, okay? So that's kind of how line of sight communications work. But let's say your radio is here in Longview and I'm in Australia. How's that gonna work? Well, that's a little different. In traditional ham radio communications, we communicate long distances the kind of the traditional way using high frequency communications. And the way that works is we have to use the atmosphere to essentially bounce a signal off a layer of the atmosphere in order to talk to somebody around the world using conventional means. And so there's different layers of the atmosphere. I won't go into too much detail on this, but there's a D, there's an E, and there's an F layer. And actually during the daytime, the F layer can separate into 2 more layers. And it's all, what controls a lot of this is solar activity. So different frequencies operate better during the day, or some frequencies operate better at night. And so what happens is, it's particularly this F layer, this is This is about 150 to 250 miles up into our atmosphere. So what happens is the sun and its radiation ionizes that layer of our atmosphere. It basically causes it to seal off, if you will. So radio signals just don't shoot out into space. And so what happens is the radio signal travels up, it bounces off here, and it goes over here. And so that's how I can communicate with someone halfway around the world, okay, in conventional radio means. And so the problem with this is atmospherics can change just in minutes. And so I've actually seen situations where that we call this effect propagation. But I've actually seen situations where I could talk with someone in Arkansas or Missouri. We could talk just fine, but I couldn't talk to somebody in Dallas. It's just the way the atmospherics are. And so sometimes it can become very challenging to communicate with that. So what happens if I don't have a tower or antenna or system that can produce the kind of power to affect this kind of communications? Well, ham radios come a long way. We've done, we still have people that do Morse code with the keyers and so on. We still have a lot of people that do that. But it's moved on. We've kind of embraced technology that includes computers and different digital forms of communication. And so what I'm going to show you here in a minute is an example of a system that we've developed that allows us to instead of using atmospherics as the long haul path for communicating around the world, we're actually using the internet now as the basis for that. So let me just erase this. Actually, I'll erase this. And what we have with this new system is, and we have this here in Longview, by the way, we have a repeater that's on a tower. What we have with a repeater is, again, we have two radios and we have a controller. And this controller is connected to a gateway that goes to the internet. And just to use a local example, this is in Longview. In Tyler, they have a similar setup. They have two radios, controller, and a gateway, and it's connected to the internet. And on the internet, we have a thing that's called a reflector. And what the reflector is it's a, you can think of it like a chat room, okay? So these, we can not only link these repeaters together, actually it happens over the internet, but we can link each of the repeaters to the reflector. And we can also have people that are out here by themselves, and this is what I'm really going to show you here in a minute, that have their own little setup that's called an access point, and their access point is connected to the internet, and they're able to connect to this reflector and talk to these people in both places. Now, this thing, these this is a guy that's got his own radio out here that's talking to this, okay? Now, I may have another guy out here that's my illustration of somebody in Australia or England or wherever you wanna call it. Let's say he's in England. Well, he's gonna connect to the internet as well. So I can actually be over here with my little box connected to the internet with my little handheld radio, and I can talk to somebody in England over the radio. He's also back over here with his radio talking to. So that's how we're using the internet and ham radio to communicate around the world. But instead of using this as the long haul path, we're using the internet as the long haul path. The reason for this is we may have some people that, like I said, don't have the resources. They either don't have the space to put up an antenna that's big enough, or they may not have the money to spend on an HF radio, which can be pretty expensive. So, you know, there's different reasons why people can't do this in ham radio, but they can do this, okay? So what I'm gonna show you is a device that uses a Raspberry Pi. I'm gonna, what this is it's called a digital ham access point. This is made by a company called Harden Power. This is actually a commercial product that you can buy. And what they've done is the product comes with not only this hardened case, but it comes with a Raspberry Pi already in it. And what they've done with this is they've externalized all of the ports on the Raspberry Pi. You'll notice on the front here, there's an HDMI port, there's a couple of USB ports, there's an audio port, a composite video port. On the back, there's a place for power. You can put an external antenna on it and I'll explain that in a minute. And then there's an Ethernet port. So what they've done is they've externalized all of those Raspberry Pi ports, so you can get to them on the outside. So if I take this cover off, remember I told you that you had this guy that had an access point out here by himself? Well, that's what we're talking about right now. This guy right here is called, this little blue box is called a DV dongle. It's called digital voice dongle. And this particular one, it's got a USB port, and you actually connect it up to a computer. The software that works with this can run on Windows, Linux, or Mac. And so you use your computer's speaker and microphone to communicate over the internet to other ham radio operators using this system. This system is called, by the way, is called D-Star. So this is if you're going to use a non-radio thing. You're just talking on the internet on your computer to other ham radio operators. This one here, what you see inside this box, is called a digital voice access point. And you'll notice that it has a little stubby antenna here. So it's actually able to communicate with a radio. So when I here in a little bit, I'm going to talk on this radio. Well, this radio is actually communicating with this little guy, okay? And on the other side of this guy, there's a USB connection, okay? And that USB connection, if I cantilever, well, I have to screw another screw here. Hold on a second. side of this it is. I think it's this one. Hold on just a second, I forgot about this other screw. Better add the wrong side. Hold on a second. Nope, that's gotta be it. There we go. Just didn't have it unscrewed enough. It's also got a rechargeable battery pack, so you can actually operate this without any plugging it into the wall. So if I cantilever this up, look what's on the other side. Your Raspberry Pi.
Well, not my Raspberry Pi.
Yeah, not your Raspberry, my Raspberry Pi. Yeah. There you go. So you see, it's got all of the connections and everything underneath that platform. So we'll swing that back down, screw that back in. So what happens is we connect the Raspberry Pi to the internet, an internet connection. And what we're gonna do is talk using this little handheld radio. Let me put this all back together so it's not all hanging out here. We're gonna see if we can talk with somebody. We're gonna connect this up over here. You're gonna have to swing around. I'm gonna hook all this up. I got something else here just before we get into this demo that I'll show you. This is another Raspberry Pi. This little Altoids tin contains a little card that allows, when we hook this up, it has two ports. It has a USB port and a serial port. And so the USB port connects to the Raspberry Pi, and the serial port connects to a radio. So the combination of this board and the Raspberry Pi and the internet connection and a regular analog radio, not a D-Star radio, but an analog radio, we can actually create a poor man's version of one of these repeaters. So if I'm,
Access point, correct?
not the access
not the
point,
access
no, not the access
The access
point.
point's in that box.
It's in the box,
Oh,
yeah.
okay.
What this combination does is it allows me to set up with another radio. It actually allows me to set up something like, and I had this at my home until we got our full-blown repeater installed here in Longview. I could drive around town and talk to my radio at home, and this combination would put me on the internet so I could talk to them.
So how do I get one of those little chipboards with the serial numbers and everything?
This right here?
Yeah, where'd you get that?
It's actually manufactured by a guy that actually lived down the road from where we lived in California.
Oh, really?
That's awesome. And you can order them over the internet.
Okay.
I think they're about, $120.
That's actually not too bad. The reason I asked is because my father does a lot of ham radio stuff, and he'd go to have one of those.
Well, you still need to have a D-Star radio.
He's got like 4 of them,
Okay.
and I've got one myself, so don't worry, we've got that.
Well,
covered.
we've got a repeater here in town.
Yeah.
So you don't actually need that.
Need.
So anyway, let me, I think I got the, well, I'll just leave it that way for now. Let me go over here, and we're gonna have to turn around. How am I doing? Am I doing all right?
Yes.
Okay.
We need a crazy shot.
Okay.
We need a crazy shot.
So,
Say hi to class 2 and class 3.
class 2, class 3.
So what I'm gonna do here is I'm gonna, on the back of this, I'm gonna actually, actually it's probably a good thing I don't have the code. I'm gonna show you something. I'm gonna hook the Ethernet cable to the back. I'm going going to hook up the HDMI port so we can see what's going on the TV. And somewhere here I've got power cable. Let's make sure we got the TV on.
Was it already on? Oh, there it goes.
Yeah, there you go. It times out.
Yeah.
So let me get us on the right source. Okay, we're already on the right source. So I'm gonna plug this in, and what should happen, there it goes. We're gonna boot up a Raspberry Pi. And what you're looking at here, you'll notice that the DV dot access point is flashing green. That means it's on. But what's going to happen eventually is once the Raspberry Pi comes up, it's going to automatically invoke a program on Linux that functions with this thing called the DVAP tool, Digital Voice Access Point tool. We won't worry about that little message there. But you'll notice now, should be able to see it. You can just barely see it, but there's another light that's flashing in there that's blue. What that means is that it now has an internet connection. Okay. So, what you're gonna notice is this is my call sign, WG5L, or phonetically is Whiskey Golf 5 Lima. This particular access point is operating on a frequency of 446.1 megahertz. And so when I talk with this radio, I'm gonna give this thing commands, and then I'm gonna be able to talk to it. So let me turn this little radio on. So what I'm going to do is I'm going to give this access point a command, and I'm going to link it to a reflector. Remember my diagram up here where we have the access point and it goes on the internet, and the reflector is connected to the internet? Well, we have different reflectors. There's a reflector that we call the Texas Interconnect. That's the 4 Bravo reflector. So if you get on that, you're pretty much talking to everybody in Texas. Another one is called the 1 Charlie reflector, and that's a more international reflector. So what I'm going to do is I'm going to key this radio. Now watch what happens up here on the screen. I'm going to key this radio, and it's going to talk to this little red box here. See?
Oh.
See, it said remote system link. So what that means is, I'm going to turn the volume up here a little bit. What it means is that I'm now, this little guy here is now connected to the 1 Charlie reflector. And by inference, this radio is connected to the 1 Charlie reflector through this access point. But you need the program on the Raspberry Pi to actually make all this happen. Okay, sure.
When you purchase that, is it already pre-downloaded, or is it something you have to go ahead and do manually?
Well, in this particular case, this software and everything is already
Okay.
preloaded on the
Okay.
Raspberry Pi. Now, there's people that come up with homebrew versions of this.
And build it with the rest.
Okay, and they have to flash the Raspbian thing onto a access card, and then they actually have to, well, I still had to configure this program. I actually had to go in and put in my call sign and the frequency that it was gonna operate on and so on. So, And this particular program, this DVAP tool program, is an excellent example of a piece of code that was written by a man called Robin Cutshaw, call sign AA4RC. And it's written, I'm not sure which language it's written in, but it's written in a language similar to Python, where it's multi-platform. This particular program runs not only on Linux, but it runs on Windows, and it also runs on Mac. So I can use this little red box, which is what this program is communicating with through the Raspberry Pi. I can run this little red box on, I can connect it via its USB port to, any computer that I've got the program on any platform. So it's a good example of something that somebody's done from a programming point of view. So let me see, I've connected to the reflector. Let me see if I can raise somebody on this. I'm gonna see if I can get somebody international. This is Whiskey Golf 5 Lima calling any non-US station. I'm currently in a class demoing a D-Star setup. I would appreciate a comeback from any non-US station.
Link currently established.
I forgot to put it on the right channel. Sorry.
To say the whole thing again.
Yeah, I gotta say the whole thing again. I often make that mistake. See, what happened was I have different channels in this radio. This is an example. You have different channels in the radio. Some channels they just send commands, but there's one channel you have to get back on in order to talk. So oops. All right, my bad. Okay, let's try this again. This is Whiskey Golf 5 Lima calling any non-US station. Currently doing a demo on D-Star. Would appreciate come back. Over.
Whiskey 5, Tango Hotel Charlie, Houston, Texas, Mark.
Whiskey 5, Tango Hotel Charlie, this is Whiskey Golf 5 Lima. I was looking for non-US stations. I appreciate the comeback, though. We will continue to try for an international station. Thank you, though.
Oh, sorry, I just turned on the radio and I heard US station. Sorry about that. 35 THC clear.
This is Whiskey Golf 5 Lima calling any non-US station. Non-US station. Over. This is Golf Tango Oscar, this is Whiskey Golf 5 Lima. What is your current location, sir?
Yeah, very good afternoon to you. Location is Bolton, near Manchester in the UK.
Huh.
Cosine Dawn,
Manchester, UK.
Charlie, Tango, Oscar, Lindsay, India, November. Thank you.
Could you give me your call sign one more time, sir? This is Whiskey Golf 5 Lima.
Yeah, cosine Golf 0, Charlie, Tango, Oscar. Golf 0, Charlie, Tango, Oscar. Okay.
Yes, sir, affirmative. I'm currently in a class that's learning programming, but we're giving them a demo on how programming is used in D-Star in ham radio, so we're kind of giving them a demonstration of D-Star. And I was hoping we would be able to get somebody overseas, and you've helped us out immensely here. We certainly appreciate that.
Okay, what's the name, please? The 0 CTO.
Ian, my name is Gary Lewis. located, I'm sorry I didn't give you our location, we're in Longview, Texas, in the United States. Over.
Yeah, okay, Gary. Yeah, nice to see you, nice to meet you for the first time. Good morning, I guess it is. The other guys in the class though. We all enjoyed it. I'm pretty much using the same as probably what you're using, which is a Raspberry Pi and a D-Flat. And a little high I just keep this generally on the bench, just to avoid the reflectors. It works extremely well. Of course, it's one of the uses of the Raspberry Pi can be extremely versatile. You can use it extremely cost effective as well. Anyway, I guess that we're probably going to get involved with Arduinos as well, I guess. Okay. So anyway, what's all this NLP? Because I know that you're in the class. And what we want to have a conversation.
These awesome British accents.
There's like a zero station. So the zero challenge,
All right, Ian, well, we really appreciate your involvement in our class this morning, and we'll hope to catch you on another time. And yes, it's about 9:20 in the morning here. What, real quickly, what time is it there?
Yeah, okay. Local time, it's 20 past 3. 20 past 3 in the afternoon. So our kids in school will probably be looking at getting out of school very, very quickly, I guess. And then finish between 3:30 to 4 o'clock in the afternoon. I don't know what time. I don't know what time you fit on up.
Okay, and we'll let you go. Sounds like you need to go pick the kids up, and we appreciate it again. This is Whiskey Golf 5 Lima out. There we go.
That is awesome.
That was cool.
That was awesome.
All those fantastic British accents. That was absolutely amazing.
Well, you know, if you look on the Raspberry Pi map, there are a lot more users in the UK because that's where it originated.
Yeah.
Yeah, I know.
That's
Just
fabulous to hear you talk about it.
By the way, what were the odds that they were using the same kind of Raspberry Pi set? That was fantastic.
Yeah.
So any questions I might be able to answer?
I've got one for you actually.
Sure.
Have you ever run into anyone by the call sign of KG5 BTF?
I don't think so.
Okay, well if you do, that's my dad. He works in Tyler. So
Oh, okay. What's his name?
Jeff Sorrells.
The name sounds familiar.
You might have met him just
Yeah,
somewhere else.
yeah. The name sounds very familiar. Any other questions? Yes?
Everyone has their own call sign. I was wondering if there's anywhere that you go in order to register your call sign, or is it just given to you?
Well, what happens in ham radio is, ham radio is a licensed service that's administered by the Federal Communications Commission. So we're assigned a block of frequencies, if you will, over the spectrum. And so what happens when you want to become licensed, you have to take an exam. And so there's 3 different levels within ham radio. The entry level is called technician, and basically allows you to communicate line of sight using VHF or UHF. Now you can communicate with this with a technician license, because this radio here, when you go on the air, you're still talking VHF, UHF, but because of this setup, it allows you to talk worldwide. So you don't need the next level of licenses. Now, if you want to do, the big boy stuff there where you're talking halfway around the world,
Gotta get general, don't
you'll
you?
need at least a general license. That requires another exam beyond technician. And if you're really going to get into the technical side of it, which I'm involved with, highest level you can get is called extra, and I happen to be an extra class licensee. Now, to answer your question about call signs, what happens initially is the Federal Communications Commission will assign you the next call sign off the shelf, if you will, for your class license. Now, what you can do is once you get that initial call sign, you can apply for what's called a vanity call sign. It's kind of like, vanity license plates you put on your car. And my call sign happens to be a vanity call sign. It's got my initials in it, WG5L. My name's Gary Lewis, of GL, Gary Lewis. The guy that I just told you about that wrote the software for this setup, Robin Cutshaw, is AA4RC. The AA means he's an extra class license. Only extra class license can get an AA call sign. And the RC stands for his, that happens to be, a call sign that he requested. So yeah.
In order to do what you just did, if we were to buy the the hardware and such, would it require a license for us to do what you just did to communicate to the UK?
You would need a license for this radio to operate this radio.
Okay.
Yeah. This setup is really not a radio. It's
Okay. Yeah, I'm sorry.
It's basically an interface setup
Right.
that allows you to communicate over the internet.
Right.
Any other questions?
How much is like one of those white boxes right there?
The whole, well, you have to buy the white box separate from this little red box. But if you buy all of that together, I think it's probably on the order of $500.
Okay.
The radio itself is probably somewhere between $400 and $500.
You gotta work with nice ones.
Well, a D-Star radio, yeah, is
That little
that little radio gun. But
Yeah.
it not only communicates this, but it also communicates on analog stuff as well, so it does a lot of things. This radio, this is, like I said, it's a D-Star radio, operates on VHF, UHF, it has a built-in GPS.
Oh, wow.
So my
when
dad's
I-
got
so
a
when
Yaesu
I-
that has a GPS dongle thing.
Yeah,
So
so when I key this up, and it communicates with our repeater, or even over this thing, it puts a code out, it actually puts my location code, so you can actually go to Google Maps and you can see me.
I can send that with my husband. He's hunting in Colorado and there's no cell service or anything.
Yeah, yeah.
yeah.
Well,
My
the
dad
other
sees-
thing that I've done, now this is another interesting thing about this box, is I'm connected via a wired connection here, right? Well, I've also got a wireless dongle in this USB port, so I can actually connect to Wi-Fi. Well, what I've actually done when I'm traveling is, and I'm on the road, I've got the equivalent of this radio in my car. It's a mobile radio, not a handheld. What I actually do is I enable my hotspot, Wi-Fi hotspot on my iPhone.
Oh.
And I've got this thing pre-programmed so it knows that it's defined in the Wi-Fi setup of the Raspberry Pi. And so it can actually connect to my cell phone and go to cell tower.
So how long will that battery last?
Well, right now I've got it connected into a wire, but the rechargeable batteries inside this white box will last for several hours. Yeah. Depending on how much usage you're actually doing. Now, what you guys may or may not realize, this whole setup of talking to a repeater here in town and it going to on the internet and it going to another repeater somewhere halfway around the world.
At that speed too.
You probably may or may not realize it, but you're doing the same thing with this. When you talk on the cell phone, this cell phone is actually a radio. It's at a much higher frequency, but it's actually a radio. And so this device is communicating via radio to a cell tower. Once it hits the cell tower, it's on the internet. It's the AT&T or Verizon or whoever it is your carrier is. At that cell tower site is connected to basically the equivalent of the internet. And so what happens is the cell system knows where you are via the identification of your phone and the location of the cell tower, the cell you're on. So if you're calling somebody in Los Angeles, for example, then the cell system knows, oh, that particular subscriber is located at this particular cell, and so it tries to communicate. It basically comes over the internet, back out that tower's antenna system, and communicates with that person's cell phone. So you're basically doing the same thing with your cell phones that we were just doing with ham radio.
So cell towers, we were in New York when they were looking for the criminals, and we couldn't make phone calls for a bit there, because there must have been, everybody was calling people or texting people. So does that happen with?
Actually, no, and that's part of the reason why ham radio communications is so important as a backup. What happens is cell providers have the infrastructure for, get this, about 10% of its subscribers. So at any given time, cell companies like AT&T, Verizon, Sprint, whoever, are expecting that about 10% of their subscribers are going to be on at any given time. Well, if you get into an emergency like a 9/11 or a Katrina or something like that, everybody's going to try to get onto the system, especially now because people have gotten rid of landlines. They're just all on cell now. And so what happens is it overloads the system. A lot of times in emergencies, it's not that the system gets wiped out and just totally gone. It's that it's just totally overloaded. And so backup communication systems like this become very important. For example, the first communications that came out of New Orleans after Katrina was a guy on ham radio using Morse code. So you never know, when we don't necessarily see hurricanes like that up here, but we might have a tornadic event that may wipe out part of our cellular infrastructure. So yeah, this form of communications can become very important in emergencies. And I also happen to be the Gregg County Emergency Coordinator for ham radio here. So, anyway, it's a lot of fun to work with this stuff, but we use it for some very serious purposes sometimes. But that's an example of how we use Raspberry Pis. There's a lot of other uses that I haven't really had the time to go into, but mainly we use them for very specialized controller type functions. Like this, we would consider a control box kind of function. You're obviously not going to run a Beowulf cluster using Raspberry Pis, but for something that's specialized like this, or something like what you guys are doing to learn programming, is perfect for that. Yeah.
I've seen on the internet that they've actually found a way to use the Raspberry Pi for a home security system. It's
Yep.
pretty neat.
Yeah, that's an example of a control function where you're using it for a very specific purpose. So the program that they're writing that for has limited functions, but it does it very, very well. Yeah. And the Pi and the Linux operating systems are very reliable operating systems. Yeah.
Is the software, in order to run the ham radio operations, is that open source?
A lot of it is, yeah. It just depends on the what it's being used for. But most of it is nowadays. Yeah, it's licensed under the GPL licensing scheme. A lot of it is.
If I wanted to prepare to be a ham radio operator, what would be my first, is there a book you recommend or a
There's
website?
several apps you can get. I've got one on my phone to take it. Once you've gotten your study time in, then there's certain times of the year where you can go and take it, right?
Yeah, what I would recommend is, there's a lot of resources on the Radio Relay League site, ARRL.org. There are apps for studying for the license exams. The local radio club, of which I'm a member, the Longview East Texas Amateur Radio Club, we have a volunteer examiner team that administers exams every third Saturday at 2 p.m. at Glaskey Engineering Center at Laterna. Every third Saturday at 2 p.m. And I believe Tyler does theirs, I think, on a Sunday at one of the churches there, I believe, if I recall correctly. I forget which Sunday it is, but they also have a volunteer examiner team that does monthly exams. So, yeah.
So are there other people in Longview that are using a similar device?
Oh, yeah, absolutely.
Do y'all have meetings that the kids could?
We have what are called nets on the air, and we check into the net. We have a person that's assigned what's called a net control operator, and so different people check into that net, and they have news or different things that they share over the air on the nets. So we try to do things using the radios, obviously.
Okay.
In terms of the D-Star stuff, there's different nets that occur. On Tuesday evenings, there's a net that's the entire Texas Interconnect net, so everybody connects on the Fort Bravo reflector. So we're talking to people all over the state of Texas. And that's actually, that net is actually, the net control operator for that net is a gentleman called Roy Chereau. He's over in Tyler, belongs to the Tyler Amateur Radio Club. So yeah, there's a lot of different nets out there. I also happen to be on what's called MARS, which is the Military Auxiliary Radio Service, primarily because of my former military background. And what we do with that is that's a completely different thing. It operates, you use ham radio equipment, but you have to modify the equipment to operate outside of its normal bounds, because the military obviously operates on different frequencies. And so those nets are much, much different. And in that case, we use different software to communicate digitally. So I'm using a computer, and I compose a message that's in a very, very strict, specific format that has to be transmitted. And I check into the net, and I say that I have, one routine, NT63, which is a mode that we use to pass to net control. And so this software that I use on the computer talks to my radio through an interface box. In some cases, those may involve a Raspberry Pi, where they're actually running the software on a Raspberry Pi. And in fact, one particular program I know runs on Windows, Linux, and Mac. So, so we actually use that software to say, okay, I want to send this message, and it converts that digital code, that program converts those digital signals into audio as input into the radio, and then the radio converts that into RF to send it over the air, and vice versa when, coming back the other way. So there's a lot of different uses for computers. As I once told a lot of different people, if you have computers and radios together, I'm there. It's just me. You're talking about two of my favorite subjects.
Awesome. Well, let's give Mr. Luke one. Great.
Now, if y'all do need another reason to go ahead and do your radio operator license and everything, even though it's a really expensive thing to do, if you do that, once you get your call sign, you can actually get vanity radio operator license plates. But once you get those, you can put those license plates on every single one of your cars. So all your cars can have the same license plate that say your call sign.
Yeah,
There.
I've actually got that.
Yeah, that's what my dad did to his Sequoia. Like, there's like 5 antennas on that thing. I swear, it's insane.